Good afternoon, Algebra 1 students. So it's Mr. Chen again. So welcome back to my YouTube channel. So guys do like the video, so please subscribe my channel. And also click the little subscription button right there. Okay, and also you're more than welcome to put in questions, comments to my YouTube channel bar. So today we'll talk about chapter 7, polynomials. So 7.1 is about adding, subtracting polynomials. So polynomial, we do have different type of terms. So we do have monomial, binomial, trinomial. So it depends on the highest power, the highest degree. Okay, so check it out, the first set of the problem, what we have right here. So write the polynomial in standard form, identifying the degree and the leading coefficient of the polynomial, then classify the polynomial by the number of terms. Okay, so let's start it off with this set right here. Okay, so this one is a little bit big, so let me just shrink the size here. Okay, so the first set of the problem is about rewriting the polynomial into standard form, and then just classify, give the name for that. So anytime they start out with 2x squared, so this one is always considered quadratic, and then so 6. And perhaps this one can be written as 2x squared plus 0x plus 6. But without the x term here, so this one is called the quadratic, because the highest degree is 2. So it's a quadratic binomial. And then the next one here, so this one looks like we started out with 5p to the power of 6 minus 3p to the power of 3 minus 4. As you can see that here, we arranged the power from the greatest to the least. So this one is called the 6th degree trinomial. And also for those who might be wondering, the leading coefficient. So the leading coefficient is always the number of the first term. The coefficient of the first term is the number right in front of the variable. So 2 would be the leading coefficient. And then for that, the trinomial here, so 5 would be the leading coefficient. Okay, so now let's see what else that we have. So for number 3, so this one it's a 7th degree trinomial. So rearrange the term from the greatest power to the least. So this one we do have 9x to the power of 7 plus 13x to the power of 5 minus 6x squared. Okay, so that would be the one. And the last one right here, this one, it's a cubic binomial. Okay, so the leading coefficient for the previous one here, so this one would be 9, the leading coefficient. And for number 4, rewrite it. So it's ay cubed minus 12y. So this one is called a cubic binomial. So the leading coefficient would be 8. So now let's see what else that we have for the next set of the problem. So the next step of the problem here is just finding the sum and the differences of the polynomial. Okay, let's check that out. So let's just do 5 and 7. So one is for addition, the other one is for subtraction. Okay, so sum and difference of polynomial. So for number 5, so anytime they want to combine the polynomials, so this one, as you can see that here is a binomial, adding with binomial. So we want to combine those like terms. So 3a plus a, you can always regroup them. So 7 plus negative 1. So 3a plus a, so that would be 4a. 7 plus negative 1, so that's 6. So 4a plus 6. And then for number 7, so we got negative y squared plus y plus 2. And then without the parentheses for the next group here, so I just want to distribute the negative 1. If you don't see the number right in front of that, the open parentheses right here, it's either positive 1 or negative 1. With the minus, so that would be negative 1. So negative 1 times y squared minus y squared. So negative 1 times negative 5y, positive 5y. And then negative 1 times negative 2, positive 2. So what we found here, negative 1y squared minus 1y squared, so that would be negative 2y squared. So negative 2y squared. And then 1y plus 5y, then that'd be 6y. 2 plus 2, then that's 4. So it's a quadratic trinomial. And now let's move on to the next type of problem. So 7.2, it's about multiplying polynomial. So normally the common one we have, it's the binomial multiplied by the binomial, because what you have to do there, you want to FOIL. And also sometimes we have to deal with binomial multiplied by the trinomial, or trinomial multiplied by a quadnomial. Okay, so now let's do 11 and 12 for this set of the problem. Okay, so I'll put it to the new page right here. Okay, so 11 and 12. So for number 11, so this one's showing that it's a binomial multiplied by another binomial. So the first binomial, it's a linear because that's the highest power is 1. But the second one, the binomial, the highest degree is 2. So it's a quadratic binomial. So the way to multiply the binomial, so we want to FOIL, it's about first, outside, inside, and last. First, outside, inside, and last. So the acronym, FOIL. So the first term, x times x squared, which is x to the power of 3. So for the last chapter, we talk about the property of exponent. So once you see the same base, multiplying the term here, so we just want to combine the exponent, so 1 plus 2, so then that'd be 3. And then x to the first power times 7x for the outside term, so then that would be considered 7x squared. And then the inner term, so 4 times x squared, so 4x squared. And then the last term, so 4 times 7x, so 28x. And normally we started off with the parentheses because it shows the consistency of the step. It's equivalent with the previous given problem. So this one just rearrange the order. Again, this one has been arranged already. So x to the power of 3. So 7x squared plus 4x squared. So then that'll be 11x squared. And then plus 28x. So it's a cubic trinomial. So now let's do the one that's a little bit complicated. So what about once you deal with the one that is the binomial multiplied by the trinomial? So in that case, so what we need to do, we need to regroup them. So negative 3y times 4y squared minus y minus 7. And then plus 1 times 4y squared minus y minus 7. So negative 3y times 4y squared, so what we found here, it's negative 12y to the power of 3. And then negative 3y times negative y, then that would be positive 3y squared. So negative 3y times negative 7, plus that would be positive 21y. So negative 3 times negative 7, positive 21. Y, just carry that over. And then the rest of those group here, so what we found here is 1 times 4y squared, so 4y squared. 1 times negative y, negative y. 1 times negative 7, negative 7. So now, from here, so this one, you got to be very careful because you want to combine the like terms. So the like term that we have, so negative 12y to the power of 3. So anything that is similar to y to the power of 3 with the exact same degree. So there's nothing like that except that negative 12y to the power of 3. So simply just carry that down. And what we have here, 3y squared, 4y squared, combine them. So then that'd be 7y squared. And then 21y minus y, then that'd be 20y. And then minus 7, so that's what we have. So it's a cubic quadnomial. And normally, whatever the final solution that you have, you always want to box it, okay? Because showing that it's the final solution set. Okay, so now let's see what else that we have throughout this whole chapter review. So the next type of the problem here, so for the next section, 7.3, it's about the special product of polynomials. So the special product, either we can expand it by using the perfect squared trinomial form, or we can use the difference of 2 squared. I think the difference of 2 squared would be one of the other section right there. Okay, so let's talk about that number 15 and number 16. Okay, so 15 and 16. You know what, I'll just highlight all of this because this one it shows like 3 different structure with the special product. Okay, so let's start it off with the difference of 2 square, so the special product. So anytime that you deal with that a plus b times the quantity of a minus b, this one is always written as a squared minus b squared. So this one is called the difference of 2 square pattern, the difference of 2 squares. And then the other one is like a plus b, so quantity square. So if this one is written as a plus b quantity square, it's the same as a plus b times a plus b. But the thing is that you want to FOIL, multiply it out, so that'll be a squared plus 2ab plus b squared. So this one is linking to the binomial expansion in Algebra 2. So you try to FOIL this, a times a times b times a, b times b, so it's a squared plus ab plus plus b squared. So another name for that is called the perfect square, the sum of a perfect square trinomial. So sum of perfect square of a trinomial. Okay, and then the other one is a minus b, similar situation. So instead of being plus, it's minus. So once you expand it, so it's a minus b times a minus b, and then FOIL, so a squared minus ab plus b squared. So this one is a squared minus 2ab plus b squared. So this one is called the difference of perfect square of a trinomial. Alright, so now let's look at that, the examples, the one that I just highlighted. Okay, so let's see right here. So using those kind of patterns, so we can find out the product of each one of these expressions, the algebraic expression. Okay, so let's start it off with 13. So 13, instead of foiling that the binomial, so what we can do, we can use that the difference of 2 squares, so x times x squared, 9 times negative 9, negative 81. And then this one's similar, difference of 2 squared, because that shows the pattern, a plus b, and then a minus b. So it's 2y times 2y, 4y squared, and then 4 times negative 4, which is negative 16. And then this one shows the pattern of the perfect square of a trinomial, so p squared. So p times 4 times 2, so ap, and then 4 squared, 16. So this one basically just one step, and then that just gives you the direct solution. And then the other one, so negative 1 quantity squared, that's 1. Negative 1 times 2d, negative 2d times 2, don't forget, so it's negative 4d. And then 2d quantity squared, so plus 4d squared. Okay, so the binomial, the perfect square trinomial, and the difference of a perfect square trinomial. Okay, so now the next problem set. So the next one, it's all about finding the zeros. So you might be wondering the expression that's given here. Well, some of those that they're already given as like a factor form. So factor form, that means there's no sign change right between the parentheses or the factor. Okay, let's take a look at that. So 17 through 20. Okay, so I just want to use the same slide right here again. Okay, so solving the equation. So the first one, you might be wondering, well, this one, there's no parentheses. Well, what we can do, we can always take out that the greatest common factor, GCF, things that they share in common. Whatever that you pull out here, you always want to divide each term by x, the greatest common factor. So what we found here, it's x plus 5. And then the other side, 0 divided by x, it's just 0. So what we have right now, it's called the factor form of a polynomial. So we do have two possibilities. So this one, that means x could be 0. And also x plus 5 could be 0. So that means x equals 0. That's one of the solutions. And also x could be what? Negative 5. And always, you guys are more than welcome to check your work. So 0, plug in the number back to the original equation. So 0 squared, 0. 5 times 0, that's 0. So 0 plus 0, it's always 0. Negative 5, same thing. So negative 5 quantity square, 25. 5 times negative 5, that's negative 25. So 25 minus 25, which is 0. So for the next one, so this one is already set. So that means z equals negative 3. And also z could be what? 7. So again, each one of those factor could be 0. And this one here, so just set that b plus 13 quantity square equals 0. So take the square root both sides. So we got b plus 13 equals 0. So b equals negative 13. So for those you might be wondering, the 2 right here, what does that mean? Well, the 2 is called the multiplicity. Multiplicity, it shows that the number of times the same solution appear. Okay, so the number of times the same solution appear. Okay, so the same solution appear. So this one, that means negative 13. How many times does that appear? So the multiplicity, then that'll be 2. So that appears twice. And then for the other one here, so we got 3 different factors. So 2y could be 0. So that means y equals 0. Y minus 9 could be 0. So that means y could be 9. And then y plus 4 equals 0. So that means y could be negative 4. So we got 3 different solutions set. So y equals 0, y equals 9, y equals negative 4. Okay, so now check it out, the next section here. So this one, we're getting to the heart and the souls of Algebra 1. It's all about factoring, okay? So there's so many ways that you can factor. You can guess and check, maybe if that's the common way your teacher is teaching you right now. The other way is like a Punnett square method. I mean, that one's kind of like guess and check as well. And also the other way, it's like a cross method. So the way that I'm going to show you, it's the one that I've been emphasizing for the other video for factoring. It's called the Smiley Face factoring. So the reason why the Smiley Face is so effective, is so efficient, is because that it's not just applying for trinomial, but it's also applying for the binomial. Okay? So, and that's what I'm going to show you next. So anytime they come up with the factor form, that means for the parentheses, the grouping right there, there's no plus minus signs right between the open and the closed parentheses. So that's how you notice, you'll get to the factor form. So here's what we can start at first. So for p squared, 2p minus 35, as you may notice, it's a quadratic trinomial. So what we can do for the first and the last term, the first term, smiley face. So separate that p squared, factor tree, the i's. So we got p and p. Negative 35, there's so many combinations. It could be negative 1, 35. It could be 5, negative 7. It could be negative 7, positive 5. But the thing is that the sum of the product of those factors must be the same as the number what we have here in the second term. So negative 35, I would like to put it this way as 7 and negative 5. The reason why that is because 7 times p, that would be 7p. See the inner product? And then outer product, so negative 5 times p right here, so negative 5p. Combine them, so then that'll be considered 2p. Okay, so same as what we have in here in the middle. So this one just shows the little indicator, so you're getting the right factor form. If the number here doesn't match with what we have in the second term, that means you have to guess and check. You have to come up with another kind of combination. So what we found here, the left-hand side of the factor tree, or the i's, so we want to group those elements together. So we got p plus 7. And then on the right-hand side of the factor tree, so you want to group those elements together, p minus 5. Okay, so that's what we got. Again, see that parentheses right here, the open close parentheses? There's no plus minus, remain. And then the next one, so again, factor it. So b squared, so bb, 80. So we need to line up that with 18, so that would be a and 10. So check it out, a times b, ab, b times 10, 10b. Combine them, so 18b. So what we can do here, so b plus 8, and then b plus 10. And then the next one, similar, so z squared, so z times z, negative 21, so then that'd be negative 7 and 3. So we got negative 7z and then 3z. Combine them together, so it's negative 4z. Exactly what we want. So z minus 7 and then z plus 3. As you can see that this kind of technique is kind of efficient and it's also is very effective. And then the last one here for number 24, so again, break it apart, the first and the last term. So that we need the nose and the chin. So this one, x squared, x and x. 28, so let's try two negative number, because the number in the middle is negative. So negative 4, negative 7. So we got negative 4x, negative 7x. So that'd be negative 11x. Again, same as what we have here in the middle. So x minus 4, x minus 7. Okay, so now let's move on to the next part of the lesson here. So what about if the leading coefficient is any other number other than 1? Would that be a little bit more difficult to applying the smiley face? Well, let's find out. So let's do some of the problem from the rest of the list here. Okay, so the next set of the problem that I would like to show you. Okay, so again, having problem with snipping the screen. So factor the polynomial, I'll just take all this. Okay, so the next type of problem. So to look at that 25, so 25 what we have right here, it's a quadratic trinomial, but this time the leading coefficient is no longer to be 1. Okay, so this one might be a little bit hectic, but that's still using the same strategy. So 3t squared, negative 12, again, so set up the structure for the smiley face. So the eyes, which is the factor tree, the nose, checking the inner product, and then the chin, checking out the outer product. So 3t squared, so we got 3t, 1t, and then negative 12. So negative 12, there's so many combinations. So it could be negative 4, positive 3. It could be negative 6, positive 2. Okay, so let's try positive 6 and negative 2, positive 6. The reason why that is, because we want to end up with a bigger positive number for the result, the sum. So t times negative 2, then that'll be negative 2t. 3t times 6, then that'll be 18t. And then 18t plus negative 2t, that's exactly 16t. Okay? You guys see that? Even that there's so many combinations, there's no need to guess and check. You can always find out the number which can satisfy the product, the sum of the product. The sum of the product must be the exact same number as the one that we have in the second term. So the smiley face, so the left hand side of the factor tree. You want to group those elements together, so 3t minus 2, just put them together. And then same thing happened with the things on the right hand side of the factor tree, so t plus 6. And that's what we found, the factor form. And what's the best way to check the work? The best way to check the work, you can always FOIL, multiply things out, and then eventually you'll end up with the exact same trinomial. And now, what else? So the next one, let's do the one with the negative coefficient. So what about if we started off with a negative coefficient? No need to worry about, pretty much the same kind of technique as what we've been going through. So negative 5y squared is just a trinomial, quadratic trinomial expression. You know, some people might be saying that, can we multiply both sides by negative 1? It's just an expression, you cannot multiply anything right here. So what you can do, just set up the factor tree, and then simply factor it directly. So negative 5 squared, so negative 5y, 1y. Okay, and negative 8, so think about that this way, so negative 22y, so that means the sum of the product of those two terms, it gotta be the negative number. So the negative number becoming more dominant. So what we can do, so this one we can set it up as negative 2, positive 4 maybe. Okay, so the reason why that is, y times negative 2, that's negative 2y. Negative 5y times 4, then that'll be negative 20y. Combine them together, so negative 22y. Okay, so the way to put this together, so it's negative 5y minus 2, and then the other one, so it's y plus 4. And for some of the student might be wondering, for the negative 1, can I plot the negative 1? Definitely, you can take out the negative 1, so what we got here is negative 1 times the quantity, 5y plus 2, change the sign, and then y plus 4, just like that. Okay, so now let's see what else that we have for the factoring. There are a lot more factoring coming up here, so we can try some of the problem here. So the one that we have looks like they have nothing in common, the greatest common factor. Well, sometimes we have to plot the greatest common factor first before we apply the smiley face, or we can do it with the smiley face first and then take out the greatest common factor at the end. And again, the factoring the special product as what we talked about earlier. Okay, so this one also we can apply the smiley face technique. Okay, so let me show you the rest of this here. So for those you might be wondering, the binomial, can we still apply the smiley face? Looks like the smiley face technique is only for the trinomial. But what about if that just considered a binomial? Does that work for the binomial? Yes, it does. Okay. Now, if you try to search up online, you don't find a lot of resources about the smiley face method because it's one of the technique I tried to create it. So if you just type in smiley face on Google search, you'll see like the same thing as what I put up there on my YouTube channel, or maybe it's something that's quite similar to it. Okay. So check it out, x squared minus 9. So you might be wondering, well, it's just a binomial, but always, whatever the missing term we have, we can always make it up. So the x term is missing, so we can just put in 0x. Doesn't exist, so 0x minus 9. Again, smiley face technique, so xx. Negative 9, so negative 3 and 3. Checking the work in the product, negative 3x. Out of product, 3x. Combine them, guess what? It's exactly what we have, 0x. Again, same old, so x minus 3, the left-hand side of the factor tree, group them together, and then things on the right-hand side of the factor tree, also group them together, x plus 3. And then the next one, similar situation. Well, without writing the 0y term, you can always break it apart, y, negative 10, positive 10, and also you can do that as well. Just make it easier, so y minus 10, y plus 10. And don't forget to put an equal sign because that shows the consistency of the word. And what about the perfect square, the difference of a perfect square trinomial? Similar strategy, so z squared minus 6z plus 9. So z squared, so z and z. So 9, instead of using 3 and 3, we're using negative 3 and 3, negative 3. So z minus 3, z minus 3. So this one is written as the product of z minus 3, quantity squared. And then this one here, similar. So m squared, so m times m, 64, 8, and 8. So it's am plus am, which is 16m. So it's m plus 8, which is m plus 8, quantity squared. Okay, so now, any other questions that you have so far? So I'm sure that people do have questions right now. So if you have any questions, you're more than welcome to put into my YouTube channel, the comment bar. And I'm more than happy to reply that within the next 24 hours. And the other one is more factoring, so it's just like a different way for factoring. Looks like we do have the one factor by grouping because it's a quadnomial. Okay, we'll take a look at that. Okay, so the quadnomial factoring, and also there's a word problem involved here as well. Okay, so let's take a look at that. So basically the last section of this unit here, it generates all kind of difficult factoring problem. And also it highlights with the word problem, things that you need to find out, the dimension of a box. Okay, so we'll take a look at that. So the word problem is actually very critical because that it's not just applying the concept what you learn, but also it's kind of related with the concept of the real life application problem. Because that, learning math, it's just like solving the real life application problem. Okay? Unless you want to major in mathematics, there's so many things that you have to prove, the concept, the theorems, the definitions, all that stuff. But in the reality, you actually have to know how to apply mathematics. So that means you truly understand what math is all about. Okay, so 35. So this one we can factor it completely. So factor it completely, that means there's no plus minus sign right between the open and the closed parentheses. So first thing that you want to check. So this one, before we use the smiley face method, we do know that the constant is missing, so 0. So this one you cannot really apply the smiley face method. So what you can do, you can take out the greatest common factor. So we take out n first, because that's a binomial. So divide each term by n. So we got n squared minus 9. And now from here, if we do recognize the special product formula, so this one is just like n minus 3, n plus 3. The difference of 2 squared. And definitely for this time right here, so you can always set it up, trinomial, smiley face, if you don't recognize the pattern. If you do, just expand it. And now let's talk about the factor by grouping. So anytime that you do have a quadnomial, that means 4 terms. So the polynomial has 4 terms. So the first thing that you always want to do, you want to regroup them. So the way to regroup them, so that means that would be x squared. Okay, let me just rewrite this part right here. So the first group is x squared minus 3x. So anything that looks kind of similar to each other, you want to always group them together. And then the other group right here, also things that look kind of alike to each other. So you just want to group them together. And then for the first group, you want to take out the greatest common factor, so that'd be x. And things that's remain, so it's x minus 3, because we take out x here. And then for the second group here, so we want to take out 4a, because that's what they share in common. Divide each term by 4a, so what we found here, it's x minus 3. As you can see that, we took out the greatest common factor of each group. And then after that, you realize that the common binomial. So for the common binomial, we want to pull out one of those, and then the rest of this. So we just want to rewrite it, so x plus 4a. So finally, the complete factorization form. There's no plus minus right between the open and the closed parentheses. And then the higher power term, let's do the one with the higher power term. Okay, so let's do 37. Okay, so 37, I'll put it right here. So again, similar strategy. So started off with the greatest common factor. If there's a greatest common factor involved here, so it looks like the greatest common factor would be 2x squared. Because that all the even number, they're all divisible by 2, the coefficients. So what we found here, it's x squared plus x, and then minus 10. And then the rest of this, we can always use the smiley face technique. So negative 10, so then that would be consider 5 and 2. Okay, but the things that 5 and 2, if you try to factor this out, it's non-factorable because this one is only 1x. So basically this one we just take out that 2x squared, and that would be the final factor form. Okay, so let's check that once again. So take out 2x squared, so it's x squared plus x, and then minus 10. Okay, so it is the final factor form. So simply take out the greatest common factor only. Okay, so now what about 38 to 41? So for this one, so let me just put it to the new page, the new slide right here. So 38 to 41. Okay, so let's take a look at that. So 38. Okay, so what we have for number, okay, solving the equation, so 38. So this one we need to factor the trinomial first, and then we want to find out the possible zeros, all the zero solution. So 3x to the power of 3 minus 9x squared minus 54x. So this one took out the greatest common factor, 3x. So what we found, it's x squared minus 3x, and then minus 54 divided by 3. So then that'll be 18. And then for the trinomial, we can factor it with the smiley face, so x, negative 18, so then that'll be negative 6 and 3. So we got 3x times the quantity, x minus 6, times the quantity, x plus 3. So set that equal to 0, so we do have 3 different possibilities. So 3x equals 0, so that means x equals 0. X minus 6 equals 0, so that means x equals 6. And then x plus 3 equals 0, so that means x equals negative 3. And then for number 40, quite similar. So this one is the quadnomial. So again, factor by grouping. So z to the power of 3 plus 3z squared minus 25z minus 75 equals 0. So regroup them. So I just want to group the first two terms together, and then the second to the last two term. Okay, so together. So 3z squared, z to the power of 3, so take out z squared. So we got z plus 3. And then this one here, we take out negative 25. So we got z minus z plus 3, because that changed the sign, negative, so that would be positive. And then take out the common binomial, so we got z plus 3, so times the quantity, z squared minus 25. And also, at this moment, you realize that this one is the difference of 2 squared. you can factor it again. So z minus 5, and then z plus 5. So what we found here, we do have 3 solutions. So z equals negative 3, and then z equals 5, and then what else? Z equals negative 5. So 3 solutions. And then the word problem, 41. Okay, let's get to that. 41. Okay, so 41, what this one is showing here. So a box in the shape of a rectangular prism has the volumes of 96 cubic feet. Okay, so the volume of a rectangular box. Okay, like that. So it shows the volume, 96 cubic feet. And the box has a length of x plus 8 feet. Okay, so the length, x plus 8. And with the width of x feet. And the height of x minus 2. So find the dimensions of the box. So dimension, that means we need to find out the exact value of the length, the width, and the height. So one thing that we noticed, to get the volume for the rectangular prism, or the box, it's length times width times the height. So what we found here, it's x plus 8 times x times the height, which is x minus 2. And the volume, it's given already, it's 96. So what we need to do, we need to factor this, well, it's already factored, so this one we need to distribute and then try to FOIL. So we got x squared plus ax. Okay, let me just fix that. And then, so that equals 96. And then what we can do here, so you want to factor it out, to multiply it out. So what we find out here, so this one would be x squared times x, then that'd be x to the power of 3. X squared times negative 2, negative 2x squared. Ax times x, then that'll be ax squared. And then ax times negative 2, negative 16x. And now this one is a non-linear equation. If that's non-linear, that means you want to bring everything together. So subtract 96. And now we end up with 1, 2, 3, 4, 5, but we can combine those like terms. So once you combine the like term, we got x to the power of 3, and then plus 6x squared, and then the rest of this minus 16x minus 96. So it's a quanomial, it's a cubic quanomial. So for those people might be wondering, how do we solve for x? Well, definitely this one we can factor by grouping. So for the first 2 terms, and then the last 2 terms. So group those terms together. So I try to put in the parentheses for this. So plus negative 16x minus 96. So for the first group here, we take out x squared. So we got x plus 6 remain. Second group here, we take out negative 16. So we got x plus 6. And then we got x squared minus 16 times the common binomial, x plus 6. So set that equal to 0. Once you solve for x, you got x equals plus minus 4, because that 4 squared, that would be 16. 16 minus 16, that would be 0. And also x could be negative 6. But keep that in mind, it's about the dimension, the distance, the length. So those numbers, they must be positive. So there's only one outcome right here, which is just what? 4. So that means the width would be 4. And then the length, plug in the number. So 4 plus 8, so 12. Let's see, 12 feet, 4 feet. And then for the height, then that'll be 4 minus 2, which is 2 feet. So the last one is a little bit complicated. It's a lot of work need to be done, need to be shown. So you need to set it up, the volume of a rectangular prism. So the formula that I need to know. Things that you learned from CC3 or pre-algebra or Common Core 3. Okay? So, and then, well, the factor form, you have to set it up there and then simply distribute and FOIL. So once you FOIL that out, it's a quanomial. So it's a cubic quanomial. So that means we have to factor it by grouping. And once you factor it completely, you find a 0. But the length, the dimension cannot be negative, so it's only one solution, x equals 4. And then once you find that variable, plug in a number, find out the dimension, the length, the width, and the height. So once again, any questions, any concerns, comments that you have, so please, more than welcome to put into my YouTube channel bar, and I try to reply that within the next 24 hours. Okay, so thank you for watching my video today. So I'll see you guys next time. So you guys have a wonderful day.